Now, welcome to one more session of maths, and we are reading chapter number 6. This is exercise 6.4, question number 6. Prove that the ratio of the area of two similar triangles is equal to the square of the ratio of their corresponding medians. Okay, दो similar triangle के areas का ratio उसकी corresponding median के square के ratio या ratio के square के बराबर है. So in 6.6 theorem we have learned that ratio of the area of two similar triangle is equal to square of the ratio of their corresponding sides. Now here sides is replaced by their corresponding medians. Okay, side की जगह side के square की जगह पे median का square का ratio आ जाएगा. Okay, so okay, what is given here? Triangle ABC is similar to triangle PQR. Moreover, ADAM and PM are respectively medians of triangle ABC and triangle PQR. Okay, so ABC और PQR ये दोनों सिमिलर ट्राइंगल है और AM है और ट्राइंगल ABC की मीडियन है, PQR है और ट्राइंगल PQR की मीडियन है और हमें प्रूव करना है. we need to prove that ratio of the area of two similar triangle means area of ABC upon area of PQR. Ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding medians. उसकी corresponding median AM and PM are corresponding medians. Okay, corresponding side पे आने वाली medians को corresponding medians भी बोलते हैं. Okay, so it's square of the ratio of their corresponding medians. Now in 6.6 theorem, here it was area of ABC upon area of PQR is equal to AB upon PQR the whole square is equal to BC upon QR the whole square is equal to AC upon PR the whole square. Now if we want to use the theorem number 6.6, then we have to replace AM upon PN by we have to replace AAB upon PQ the whole square by AM upon PN the whole square. So we need to set the relation between AM upon PQ, AB और PQ और AM upon PN का रिलेशन सेट करना है. तो हम AB अपन PQ की जगह पे AM अपन PM लिख पाएंगे. ओके, और इसके लिए क्या करना होगा, हमें ये दोनों ट्राइंगल को सिमिलर प्रूव करेंगे. तो AB PQ ये कॉरस्पॉन्डिंग साइड एक पैर है, AM एंड PM कॉरस्पॉन्डिंग साइड की दूसरी पैर है. अगर इस दोनों ट्राइंगल को हम सिमिलर प्रूव कर सके तो ये हो सकता है. ओके, सो वी विल गो फॉर इट. ओके, now proof. Here AM, okay, AM and PN are medians. So therefore BC is equal to 2BM and QR is equal to 2QN. पहले भी हमने ऐसा किया हुआ है. ओके, सो नाउ माय फ्रेंड्स, triangle ABC is similar to triangle PQR. Okay, it's given. So we can write that AB upon PQ is equal to BC upon QR and angle B is equal to angle Q. ओके, दो ट्राइंगल अगर सिमिलर है तो उसकी कॉरस्पॉन्डिंग साइड का रेशियो सेम है. AB and PQ is one pair of corresponding side, BC and QR is the other pair of corresponding side. और उसकी दो ट्राइंगल अगर सिमिलर है तो उसकी कॉरस्पॉन्डिंग साइड का रेशियो सेम है and their corresponding angles are equal. So B and Q are corresponding angles, they are equal. Okay, now my friend, therefore now in place of BC I would write 2BM, and in place of QR I would write, it's a QR, in place of QR I would write 2QN. So AB upon PQ will be as it is, and now in place of BC it will be 2BM, and in place of QR it will be 2QN, and angle B is equal to angle Q will remain as it is. Now if we get these two cut, we get AB upon PQ is equal to BM upon QN, and angle B is equal to angle Q. Look at it, these two triangles, AB upon PQ, here it is equal to BM upon QN, is it? And angle B is equal to angle Q. Now as per SAS, side angle side criteria, now we can write these two triangles to be similar to each other. So therefore triangle ABN is similar to triangle PQN as per SAS criterion. Okay, and therefore if these two triangles are similar, their corresponding sides are proportional. AB upon PQ is equal to AM upon PN. Okay, this is number 2. Okay, so here we used result number 1 from 1. Okay, now from here it is from 1. Now my friend, we know that ABC and PQ are similar triangles. Triangle ABC is similar to triangle PQR. Once again it's given. Now area of ABC upon area of PQR is equal to AB upon PQ, the whole square. It's from theorem 6.6. As per theorem 6.6, area of two similar triangle is equal to square of the ratio of their corresponding sides. Now my friends, we have set the relation between AM upon PQ and AM upon PN. So in place of AB upon PQ I can write AM upon PN. So area of ABC upon area of PQR can be written as AM upon PQ, AM upon PN, the whole square. From it is from result number 2. Okay, from result 2, in place of AB upon PQ we can write AM upon PN, and hence proven. Look at it, this was the mathematical sentence required to be proven. Okay, very good. Now question number 7. Prove that the area of an equilateral triangle described on one side of a square. Okay, स्क्वायर की एक साइड पे डिस्क्राइब किया गया हुआ इक्विलेटरल ट्राइंगल है, उसका एरिया इज इक्वल टू हाफ द एरिया ऑफ द इक्विलेटरल ट्राइंगल डिस्क्राइब्ड ऑन वन ऑफ इट्स डायगोनल. उसके वही स्क्वायर के एक डायगोनल पे डिस्क्राइब किए हुए इक्विलेटरल ट्राइंगल के एरिया से आधा होता है. ओके, सो लेट अस draw a square. A square is here. Look at it, a square here. So first of all, I will draw an equilateral triangle described on one side of a square. Okay, so you know that equilateral triangle can be described on if the length of one line segment is given. So I would like to describe this equilateral triangle on AB. So distance AB को consider करके हम equilateral triangle describe कर सकते हैं. If C is here, it's P is here, then look at it. This one is an equilateral triangle, APM. Okay, so APB is an equilateral triangle described on one side of a square. Now उसका एक डायगोनल BD डायगोनल लेते हैं और BD डायगोनल पे हम एक इक्विलेटरल ट्राइंगल डिस्क्राइब करते हैं. सो B और D को कंसिडर करो तो यहाँ पे अगर एक तीसरा पॉइंट मैं ले लूँ तो look at it. This is the equilateral triangle described on, it's a Q. So triangle BQD is described on diagonal of the square. So this one is the equilateral triangle described on one side of a square, and this one is the equilateral triangle described on one of its diagonal. Okay, now to set the relation, ये ट्राइंगल और इस ट्राइंगल के एरिया के बीच का रिलेशन सेट करने के लिए हमें क्या करना होगा, हमें AB और BD के बीच रिलेशन सेट करना होगा. यानी स्क्वायर की साइड की लेंथ और उसके डायगोनल के बीच का हमें रिलेशन सेट करना होगा. ओके, so given, what is given? Triangle APB is described equilateral triangle. So equilateral triangle APB is described on side AB and AB of square ABCD and equilateral triangle BQD is described on diagonal BD of square ABCD. Okay, now what we require to prove? We require to prove that area of a triangle described on one side of a square is half the area of the equilateral triangle described on one of its diagonals. So area of APB is half the area of PQD. Okay, that we want to prove. Now proof. So look at it. This is a triangle, right triangle. Okay, so triangle ABD is right angled at A. Okay, and therefore as per Pythagoras theorem BD square is equal to AB square plus AD square. Okay, my friends, but AB square and AD square are same. So in place of AD square, I can write AB square because AB and AD both are the sides of a square. So, okay, so therefore BD square is equal to 2 times of AB square. Okay. Now BD square is, therefore BD square upon AB square is equal to 2. So I can write that, therefore BD upon AB the whole square is equal to 2. This is result number 1. Okay, my friends. Now triangle APB and triangle BQD are equilateral triangles. Equilateral triangles. Okay, and so therefore triangle APB is similar to triangle BQD. Okay, two equilateral triangles are always similar, that we have discussed, that we have discussed earlier in this chapter. So these two triangles are always similar. Okay, and as per side criteria also. Okay, and therefore area of APB upon area of BQD is equal to, so as per 6.6 theorem, area of two similar triangles is equal to square of the ratio of their corresponding sides. So AB upon BD. Okay, so AB upon BD the whole square, but AD upon BD is equal to AD upon BD the whole square is equal to 2. Okay, so therefore we can okay, AB upon BD, sorry, it's a BD upon AD, so it's area, it's a BD upon AB. APB is this one and BQD is this one. So AB is the small size. Okay, sorry, AB upon BD. So AB upon BD would be half. Okay, so BD upon AB is equal to 2. Then we can write that. Therefore, AB upon BD the whole square is equal to 1 by 2. Okay, now it's a 1 by 2 the whole, 1 by 2, not 1 by 2 the whole, it's a 1 by 2. So therefore area of APB is equal to half the area of BQD. Okay, and then it was to be proven. Very good. Now question number 7 and question number 8, they are very small questions of option. Okay, so you can solve it by yourself, and giving you this question number 7 and 8 to be completed by you. Okay, in homework. Now theorem number 6.7. See, we have to learn the theorem 6.7 and prove 6.8, which is Pythagoras theorem, and we need to prove it. But before we prove the Pythagoras theorem, we have to discuss the theorem number 6.7. Okay, now if a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse. Okay, so right triangle के right angle से, फ्रॉम द वर्टेक्स ऑफ द राइट एंगल के वर्टेक्स से हम हाइपोटेनस पे अगर परपेंडिकुलर ड्रॉ करते हैं, क्या होता है देखते हैं. ओके, BD. So a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse. राइट ट्राइंगल के राइट एंगल्स के वर्टेक्स से हमने हाइपोटेनस पे एक परपेंडिकुलर ड्रॉ किया, तो हमें दो ट्राइंगल मिले. this one ADB and BDC. Okay, it's okay. Then the triangles on both side of the perpendicular की दोनों साइड एक एक ट्राइंगल मिले आर सिमिलर टू द होल ट्राइंगल. अब ये दोनों ट्राइंगल है आर सिमिलर टू द होल ट्राइंगल. दोनों ट्राइंगल है वो होल ट्राइंगल ABC को सिमिलर है एंड टू ईच अदर. ये दोनों एक दूसरे को भी सिमिलर है. ये हमें प्रूव करना है. ओके, नाउ माय फ्रेंड्स, वी जस्ट डिस्कस इट. ओके, सो वन ट्राइंगल इज triangle ADB, okay, triangle BDC and whole triangle ABC. Okay, we just discuss it. Okay, look at it. This is triangle okay, we need to prove that it's A, B, C and D here. This is right angle. It's A, B, C, AD. This is right angle. Sorry, it's a B here, A here, and this is A, B and C. Now my friends, look at it. We need to prove that triangle ADB is similar to triangle ABC. Okay, so how it is possible to look at it? This triangle sorry, we don't want this. This is, so we have to prove ADB with ABC. See, one angle is common in both. Angle A is equal to angle A. Okay, and angle D is right angle here, whereas angle B is right angle here. So one angle is common. Angle A is equal to angle A. Okay, angle A is equal to angle A. Moreover, angle ADB is equal to angle ABC here, angle ABC. Okay, and therefore using this criteria we can prove that angle ADB is similar to ABC. And look at the correspondence. A is corresponding to A, B is right angle, D is right angle, so D is corresponding to right angle, a right angle is corresponding to right angle, a common angle is corresponding to a common angle, a right angle is corresponding to right angle, and the third angle is corresponding to the third angle. Okay, so ADB, look at it, ADB is similar to ABC. Okay, now my friends, hence it is proven. Now in these two triangles, in this triangle BDC and ABC. Okay, now look at it. Angle C is common in both. Angle C is common in both. Look at it. Angle BDC and ABC. Angle C is common in both. And in this triangle BDC, D is right angle, whereas in this triangle B is right angle. So triangle BDC is similar to triangle dash dash dash. So C is corresponding to C. So C here, C is corresponding to C. Now D is right angle. So right angle is corresponding to right angle. Here it is D. So here it is B. Okay, and the remaining angle is A. So here BDC similar to ABC. Okay, now look at it, and therefore triangle BDC, okay, it's already written, BDC is corresponding to ABC. Now look at it in this result number 1 and this is result number 2. Okay, result number 1 and result. So in both the result, ABC, triangle ABC is common. ADB is similar to ABC and BDC is similar to ABC. So if two triangles are similar to the same triangle with the same correspondence, therefore ADB will be similar to BDC. So we can write that triangle ADB is similar to triangle BDC. Okay, so ADB is similar to BDC. So you keep on memorizing the correspondence that ADB similar to ABC, BDC similar to ABC, and ADB is similar to BDC. Okay, so we will use this result in the Pythagoras theorem. Okay, very good. Now theorem number 6.8, Pythagoras theorem. The Pythagoras theorem is very popular among the students. And we have been using the result of Pythagoras theorem since standard 8. Okay, so in a right triangle, look at it, this is a right triangle. In a right triangle, the square of the hypotenuse, see, opposite side of a right angle is the hypotenuse. So square of the hypotenuse is equal to the sum of the squares of the other two sides. Okay. So in a right triangle, the square of hypotenuse, this is right angle, square of hypotenuse is equal to the sum of the squares of the other two sides. Okay. Now, my friends, what is given here? Triangle ABC is right angled at B. Okay, so triangle ABC है उसमें B right angle. So this is a right triangle. Now what we want to prove? We want to prove that sum of the square of hypotenuse, square of hypotenuse rather, AC का square, AC square is equal to sum of the squares of the other two sides. It's AB square plus BC square. Okay, so AB square plus BC square, that we want to prove. Now proof. Okay, so my friends, here it's AC square is to the left hand side and AB square plus BC square. So taking right hand side first, we will prove the left hand side. So हमें AB square और BC square दो चाहिए, उसका रिजल्ट चाहिए और उसको हम ऐड करेंगे. Now my friend, for that हम 6.7 थ्योरम का यूज करेंगे और इसके लिए हमें ये है परपेंडिकुलर ड्रॉ करना पड़ेगा. ओके, सो let BD perpendicular to S. Okay, so as per theorem, as per theorem 6.7 क्या लिखेंगे हम? Now we want AB square. तो देखो इसमें AB स्क्वायर चाहिए, यानी ऐसे दो ट्राइंगल को हमें सिमिलर लिखना है जिस दोनों ट्राइंगल में AB उसकी एक साइड है. सो ADB उसकी भी एक साइड AB है और ABC इसकी भी एक साइड AB है. So we can write as per 6.7 theorem ADB similar to ABC. You can write ADB similar to ABC. Triangle ADB similar to triangle ABC. Now we want AB into AB. How it is? We know that ratio of side of similar triangles are proportional. Okay, so यहाँ पे लिखेंगे हम AB. We want AB. तो AB के नीचे यहाँ पे क्या लिखना पड़ेगा? AC. and look at it, AB is here, so AB we can write AB here, तो उसके ऊपर हमें ये लिखना पड़ेगा AB. Okay, so we can now write that AB upon AC is equal to AD upon AB. दो सिमिलर ट्राइंगल का के कॉरस्पॉन्डिंग साइड का रेशियो इक्वल होता है. Okay, so we can write, therefore we can write AB square, AB into AB square is equal to AD into AC. Okay, this is result number 1. Now we also want BC square. We also want BC square. And BC square यानी BC कौन से दो ट्रायंगल की साइड है? एक BDC में भी BC है और एक ABC में भी BC है. तो हम इसका यूज करेंगे BDC into, so similarly from theorem 6.7 we can write that triangle BDC is similar to triangle ABC. So triangle BDC is similar to triangle ABC. Now we want BC. So look at it, BC. So BC upon AC. Okay. और यहाँ पे BC. So DC upon BC. So BC upon AC is equal to DC upon BC. Okay, so we can write BC into BC is a BC square is equal to DC into AC. This is result number 2 or equation number 2. Now we want AB square plus BC square. For that we have to add 1 and 2. So adding 1 and 2, what do we get? It's AB square plus BC square. ओके, अब दो इक्वेशन को अगर हम ऐड करना है तो दोनों की लेफ्ट हैंड साइड का एडिशन होगा इज इक्वल टू दोनों की राइट हैंड साइड का एडिशन होगा. ओके, सो AB स्क्वायर प्लस BC स्क्वायर इज इक्वल टू AD इंटू AC प्लस DC इंटू AC. ओके, सो AC कॉमन इन बोथ. It will be AB plus DC here, and now look at it. AD plus DC. Here it is AD plus DC. So AD plus DC will be AC. You can see that it's AD plus DC is equal to AC. So AD plus DC is also AC. AC into AC, that is AC square. Now look at it. AB square plus BC square is AC square. It is proven. So therefore we can write AC square is equal to AB square plus BC square. Okay, so this is how we can prove this Pythagoras theorem. Very popular. Okay.